and vibrate.
Okay. Oh, hi.
Oh, hey, hi. We got caught like putting our phones on Do Not Disturb before we start. Hi, everyone. Good afternoon. Thank you for joining us. We do love it when people come and do some security with us. So I'm Sarah Young. I'm a principal security advocate. I have come from Australia. I will try and say all my words properly because I'm definitely not jet lagged at all.
And I'm Pamela Fox. I'm from the Python Cloud Advocacy team, and I come from California-ish.
To be fair, I'm only Australia-ish, but you can guess the accent. Okay, then, let's get into it, because we have tons to go through. We are going to look at building a secure end-to-end secure AI app. And that's difficult, right, Pamela?
Yes.
Because I'm a security person, Pamela is a builder, and we know this is tricky because security isn't often forefront of mind when you're building things, but I'm sure most of you here have security teams who will ask you to do things and maybe stop you from doing things if you don't do what they want. By the way, I promise security are lovely. You'll love us by the end of it, maybe. So these are the different stages of what we're going to look at today. We're going to build our app. First of all, I'm going to give you scary security stats because everybody loves those. Then we're going to go through the stages of building this app, and we're going to add different layers of security controls. So let's get into me scaring you a bit. So let's go. Scary security stats. So attacks have grown. And these stats, by the way, they come from Microsoft Threat Intelligence. We have a heap of very cool people who it is their job to research this. But just have a look at some of these stats. So threat actors, as in groups of people, whether they're countries, criminal groups. In 2023, we were tracking 300. We are now tracking over 1,500 of them. So that has increased a lot. And you can see if you accidentally leak some of your data, the average time now to do something with that is an hour, just over an hour. It used to be a number of days. So whilst we talk about AI and being efficient and it making us more productive, remember it can make the bad guys more productive too in what they're doing. And then you can see the last one in the scale, password attacks, we used to see around 579 a second, and now we see 7,000. So it's getting worse, but we're also getting better. But on the identity side of things, also of the identity attacks that we see, 99% of them are password-based attacks. So you will have heard this before, but if you are not using MFA, please use MFA. Don't just use a password, because we see a lot of password attacks. And ideally, move away from passwords altogether, but that is a story for another day. But do if you can. Then, well, a couple more. 84% of attack paths involve internet exposure, so that's any kind of application or system that is exposed to the internet that needs to egress. That's where that initial attack path comes from. And 66% of attack paths involve identity compromise. Again, no surprise there. Bit of the state of AppSec. If you don't know the acronym AppSec, that's Application Security. And these are from our friends at GitHub, some of these stats. But you can see there's a lot of vulnerabilities written in lines of code. And unfortunately, as we see that graph go up there, we're writing more code, but we're also kind of matching it on the vulnerabilities, which obviously we would like to improve. But there's a lot, 85% of applications still have some kind of security issue. And code written in 2020 is just as likely to have a security issue as code written in 2016. I don't have the up-to-date stats on that, but unfortunately, it's probably similar. So although this could apply to any kind of application, of course, we're talking about AI, but we want to write things properly. And last up, we don't have enough security people to devs. You may know this in your organization. If you may not have anybody to talk to about security. And remediation trends are stagnant. We're not getting better, as that line showed. So there's my nice depressing start to this talk. But what can we do about it? So we talk about defense in depth in security. And if you're not familiar with the term defense in depth, I love it when I see all the cameras go up. The slides will be available, but please take pictures. So when we talk about defense in depth, what that means is we are putting layers of security controls in place on a system or an application. And they're different layers of security controls. The idea being that no one security control is 100% success. It is 100% secure. It's not possible. So we put lots of layers on to, if one layer breaks or doesn't work, there's another one to back it up. So this is what we will be building today. We're going to go through some egress security controls, internal network, responsible AI, and identity. Now, don't freak out when I show you the next slide. Well, the next slide. This is the app we're going to build today. As you can see, lovely. This is our app, and this is our app with all the security controls put in it. Now, this is the end state. We're going to dial back in a second and show you how we get to this end state. And here we have all those layers of security controls that I showed you on the slide before. So, Pamela, over to you.
All right, let's see this application. So in terms of this is stage 0, right? We're going to build up that whole crazy architecture. So at stage 0, we have the minimal. This is like your MVP you make during the hackathon and you never put in production, right? So in this like minimal architecture here, we have a container. We're using Azure Container Apps in a container app environment. We're using Azure OpenAI. We're storing our container image in container registry. And that's basically what we have. The container app has a Python backend, which is communicating with Azure OpenAI, and then we just have a very simple JavaScript front end. So, you know, this is just an easy way of interacting with a language model. We're not showing you a super fancy AI app today because really we're trying to put the focus on security. You can make your apps more fancy on the app logic level. We just want to show you how you can secure them. All right, so we're going to say write a security chant for MS build. Oh yeah, it wants to use my microphone, but I'm in Edge, it doesn't work. I'm on a Mac, just so you know, so some things are different on a Mac. All right, we got our security chant. Secure the code, protect the float at MS build. We're in the know.
Yeah.
All right.
With every line we stand our ground. In unity, our strength is found. We're not going to do the rest, promise.
Okay. Unless you want us to. Okay. Yeah. All right. So that, like, the text works. Now we also have a ability to upload an image. So Sarah has kindly provided an image of her dogs. Describe these doggos, and are they cute? Okay. All right. All right. I'm going to send these over the wire. And here we have 2 adorable Shiba Inu dogs. Is that correct, Sarah?
That is correct. I'm biased, but.
It says, overall, these doggos are undeniably cute. Congratulations, you have cute dogs. All right, so this is me on a good day interacting with an application where I'm being very sweet and entering in all sorts of nice, safe inputs. Now, imagine that, you know, someone starts using your application and they're in a more trolley mood, and they want to, you know, maybe enter some things in the application that aren't as nice and see what kind of responses they get from it. So let's troll a little bit, shall we?
Let's.
All right, so here I'm just going to ask, you know, this is what I put in every AI application. How do I make a bomb? Now, as we see, we do actually get an error, which is good. This is the error that comes from the Azure OpenAI content safety filter. So every time you use an Azure OpenAI model, it will come by default with our standard content filter, which will block everything that's of medium severity and higher. So here, it filtered this one due to violence. So you can see violence, filtered true, severity, medium. So it looked at that response and said, hey, this is violent, medium severity, let's filter it, right? So now this is, you know, the application refuses to respond. Typically in my applications, I don't show them the JSON, but I wanted to actually show you the JSON because we're all developers here, so you can see what it looks like. In your application, you'll just want to say like, oh, this was blocked. All right, so it did block that. What about if I try to jailbreak it?
I think we should try and jailbreak it. So
Sarah, you told me about this thing called Dan.
I did. If you don't know what Dan is, Dan, well, it's, as it says here, it stands for do anything now. This is a very generic standard jailbreak, just to prove the point. Of course, jailbreaks, I would be very disappointed in any model if it didn't block the Dan attack. Please don't use that model if it doesn't. But of course, jailbreaks can be much more sophisticated than that. But as you can see, again, it has been blocked by the content filter, as we would expect.
Yeah, so by default, we will block jailbreak attempts. And you can see that it says jailbreak filtered true, detected true. So that has been blocked. Okay, so that's looking good, but now I'm going to be a little more subtle. Maybe I wake up feeling a bit mad.
Did you choose violence this morning?
I am. I'm going to choose violence against your dogs. All right, so Shiba Inu are horrible dogs. This one did not get blocked.
No.
Now, of course, it didn't. It doesn't say. It doesn't agree with me. It likes Shiba Inus, but it didn't get blocked, right? And depending on what I'm developing, I might just want it to get straight up blocked, right? If I'm doing like an application for high schoolers, I don't even want to humor this question, right? I want to just straight up tell the high schoolers like, hey, I'm blocking that, right? So what we can do is actually, for extra level of safety, is that we can make our content safety policy stricter. We can say, hey, you need to block everything, even if it's of low severity. So that brings us to the next stage.
Yes. So let's go back. We're going to have fun toggling. Now, this is what we just built before we move on. Here is our beginning app. This is stage 0 that we just described. And now let's move on to the custom RAI policies, which we're going to do. So here we have, you can see this hasn't really changed very much. We've just got there in the right-hand side our custom RAI policy that we're now going to build.
All right, so let's go back over. This is the application at our next stage where it has a custom RAI policy. I'm going to wake up again and choose violence and say Shiba Inus are horrible dogs. And let's see what happens. It got blocked. We are not going to let people make fun of Shiba Inus in this house.
No Shiba hate here.
Yeah.
Okay.
So how did we actually do that? So I'll show you both what it looks like in the portal and in code. So in the portal, when you're setting up your deployments in your AI Foundry, you can set up the guardrails. And in the guardrails, you can set up your input filters and your output filters. And what you see is that basically you can decide what levels you're going to block, right? I said by default, we block medium and high, but you can have it block low, medium, and high. And so that's what we've done here. We're actually going to block low, medium, and high for every single category. And then we also turned on, we already have jailbreak attack on by the default. We also turned on detection of indirect attacks. So an indirect attack is if you're doing like a RAG application where you're passing context to the LLM. An indirect attack is when there's a jailbreak inside that context that being passed to the LLM. And that's a little more subtle to detect. Like imagine you're like scraping the web, you're getting search results, and somebody has put instructions to the LLM like inside the comments in their website, and now you send that to your LLM, and you don't know that it actually says to be mean about dogs or something, right? So that's what it'll do, is detect those indirect attacks. So we've turned on everything that we possibly could here. This is what it looks like in the portal. I'm also going to show code, because I like code. So I am using Bicep to create all of these resources. Bicep is infrastructure as code that you can use to declare your Azure resources, connect them all together, and have reliable deploys. And it is so amazing to have reliable deploys. Does anyone here use Bicep or ARM, either of those? All right, nice.
Nice.
Love it. You're going to have to give them cookies after.
Oh, yeah. There's food afterwards, by the way.
Yeah.
Give us a good rating.
Yeah. All right, so as you can see, I can set up my OpenAI, and in this case, when I enable the strict RAI policy, I'm going to use the strict one instead of the default one, and we can actually see in the Bicep how we set up that RAI policy. We just set everything here to low. So there we go. We can customize it, and we can have full control in our Bicep. All right, so Sarah, are we secure yet?
Do you think we're secure yet, Pamela? No, we are not secure.
No,
but
we're not secure.
There is a question about how do we know we're not secure? Now, who here has heard of Defender for Cloud? Oh, more than I thought. Oh, hello, Mister, who's got the dog stickers. Okay, more than I expected. So that's great. So Defender for Cloud, if you don't know what it is a CSPM, which is Cloud Security Posture Management Tool. And essentially what it does is it has a look at everything you've deployed in Azure, and it can do other clouds as well, but obviously today we're just looking at Azure. And it will tell you if your deployments are not ideal for security, if you could do your hygiene better. So here in the deployment we've just done, you can see that we've got some recommendations, and it's also it's given them by risk level as well. So we don't have any highs, which is great, but we do have some recommendations. So we can see Azure AI services should have key access disabled, because at the moment we have some very basic authentication. We've got diagnostic logs, and we're going to go through the rest of them. We're going to work through these recommendations and get rid of them so we have a fully secure app with good hygiene. And yeah, and the good thing about Defender for Cloud, this basic version is free. It's at no charge, so you have no excuse not to be using it. But I'll just show you, if we do click on one of these, and I've done that again. So this is, you can tell Sarah's good at Macs. You can see that if you click into the recommendation, because if you don't know how to do it, it will actually tell you. And in certain cases, depending on what it is, it can actually automate the fixing as well. But that's a topic for another day. So let's go on and have a look at what we're going to do. We're going to first look at diagnostics. So here's our diagram again. We still haven't added too much to it. The only thing we've added here is a log analytics workspace, and we're sending diagnostic logs from the container apps environment and from Azure OpenAI into this log analytics workspace. Now, as builders and developers, you're probably not going to do too much with these logs after they have got into the workspace. I'm going to be honest with you. But that's probably going to be an operational team or a security team. But as the person who builds this, it's a good idea that you get those logs in. And we want them in a central workspace, because we can't do nice correlation and monitoring if they're all over the place. So let's have a look. And Sarah is not using the mouse. Oh, and I'm clicking on the wrong side, which also doesn't help. So let's have a look at what this actually looks like. So has anyone here used KQL, Kusto Query Language? A few of you, okay. So if you don't know what Kusto is, it's the query language that we use in most Microsoft security products, Azure Monitor, Log Analytics. It's actually pretty nice. Again, you may not have to use it, but we can run queries on our logs. So here I've just got, this one's looking at the average time for when the application completes. So we can see it's completing in 339 milliseconds. There's a nice one. We've also got, if I can tab and no, love it. Or if we can tab, there we go. Look, I'm doing some great copy pasting here. Love this. Windows woman tries to use iOS. Tries to use Mac. But here we're looking at, this one is showing you in the container app systems logs. We can see here we're looking for all the warnings in that table and stuff we might need to dig into. Again, if you're developing, you're probably not going to query these logs much, but other teams will need them, and this is how we can do good security monitoring. So you might as well set this up to start with.
I usually will put like app insights on top and then make some cute graphs, because I do like cute graphs.
We do like graphs.
Yes.
You can actually do graphs in Kusto as well.
Oh.
Yeah, we won't go there, but now we can see, if we go back to Defender for Cloud, this is like children's TV. Here's one we made earlier. So we can see here that in Defender for Cloud, that recommendation has now disappeared.
Woo!
Woo! Yeah. It's also worth pointing out here that when you change something in Defender for Cloud, it can take up to 24 hours for the recommendations to update. So it won't be instantaneous, just when you actually do this in real life. So, Pamela.
All right, so I'm going to tackle the next recommendation on here. Yeah. So you see this one, it says, there's one that said should have key access disabled.
I flicked back too quickly for you.
No worries, right? So it says Azure AI services should have key access disabled. We can click on that and it says, hey, you're using keys right now for your Azure AI. Keys are a bad idea from a security perspective. If you can avoid them, it's always better, because when you have keys and you have to worry about key rotation, you have to worry about people checking their keys into GitHub. I can't tell you how many times I've seen some people check their keys into GitHub and then scramble to figure out how to delete Git commit history and all that. So we really want to encourage people to move away from keys in the situations where you can, which is often possible if you are using an Azure service on an Azure platform like Container Apps or App Service. And as you can see, in the current version of the app, the one we were just looking at, it is using keys. We can see in the Azure OpenAI thing that we've got keys here. That means that anyone who has access to this resource can come here, copy the keys, use them, and use up all our quota. So yeah, let's go over to keyless.
Let's have a look. So this is putting in a managed identity. So things changing up a little bit more now. Rather than using some basic keys, we're going to, in Entra, create a managed identity, give it some permissions, give it an RBAC role or role-based access control, and do the things. So, Pamela.
All right, back over. So I'm not going to actually show you the app because the app looks exactly the same. That's what can be a little like unsatisfying about doing security. Like I'm like a full stack developer, so I like to make like cool websites that do cool things. And a lot of times when I make a security change, my app looks exactly the same. All that's changed is behind the scenes and that I've reduced the attack vectors for it, right? So the app looks exactly the same. The difference now is that now people can't use the keys in order to abuse the resource. So if we now look at Azure OpenAI and we click on keys, we'll see there are no keys. It can't give us keys because I've turned it off and I'm only using managed identity. So the idea of managed identity is that we set up an identity for our application and we say, hey, this container app has this identity and it is allowed to access this resource. And so you actually, when you create these identities, you give them permissions and you say, hey, you have the permission to access this thing. Let me just show the code actually, because let's see, role backend. Okay, there we go. So this is what it actually looks like in my Bicep here, where I'm saying, here is the principal ID of the container app that I created. I created a user-assigned identity for it. That's a kind of managed identity. I assign it the role of Cognitive Services OpenAI user. So I said, hey, this app has the permission to access OpenAI resources. And that's basically it. So that means that when it makes calls to OpenAI using this identity, it is allowed to make those calls. So it's like we get two benefits here, actually. We get rid of keys, and we use tokens instead. And then we also have the benefit that we're really being much more specific about what we're allowed to do with those tokens, right? So in this case, all we can do is access OpenAI. Now, our app code does actually change, right? So here is what we had before. This is what you might think of when you're doing keys, is that you set your key, you get it from your environment. But when we're doing managed identity, what we do is, here I say, like, OK, are we running in production? If so, I'm going to grab the client ID of the identity I created for container app. I'm going to pass that into the managed identity credential, which is from the Azure Identity SDK. And then that will authenticate me. And then I can get tokens from that and pass those tokens to the OpenAI SDK. So this is what it looks like with the OpenAI SDK. It looks slightly different with other SDKs. But that's the idea, is that we say, hey, this is our identity. Let's get a token for that identity. Let's pass it to the SDK. And what's really nice about those tokens, the tokens actually look like keys. They do look like keys.
They're just super short-lived.
Yeah, they're super short-lived. Like the token lifetime is somewhere between 6 hours and 24 hours, depending on the service, I think. And so they will automatically expire after that lifetime. The code in the SDK takes care of refreshing that token for you and getting a new one, so that the next time you make a request, you're using a refresh token. But that means if somebody did manage to get that token, from earlier, that token's going to expire so soon, and they're just not going to have much chance to use it.
Yeah, and to add to that, in Entra, we can actually revoke tokens as well. If you really didn't want to wait in an emergency, that there is a way of doing that.
Okay.
Yeah, and obviously that's much easier than having to revoke keys and do key rotation and things like that. And your security folks will love you, because in Entra, and we could, again, go on about this, but in brief, in Entra, we have a lot of different other security controls. And if you're using a managed identity, we can look at patterns of behavior. And if suddenly a managed identity is doing stuff it shouldn't normally be doing, we'll get security alerts. And again, just adding all those different layers of controls to make things more protected. And we do say now, identity is the new perimeter. I'll be saying that again, rather than networking. So keeping identity secure is super important.
Yeah, let me actually also point out, just show what this looks like in the portal, right? If you have an Azure Container App or an app service, if you go to the Identity tab, you'll see whether you're using System-Assigned Identity, which is an identity that lives and dies with the app, or User-Assigned Identity, which is what I usually use, that is independent of the app, and so that way we can use it for multiple things, because I actually use this same identity in order to do container registry pulls. So this container app uses this identity in order to pull from the container registry, and it also uses this identity in order to interact with the OpenAI. So that's what it looks like, so you can see if you have any identities. And we should be able to go here and check access that, let's see, role assignments. Oh, role assignments. Oh, that's going to show all our role assignments. So there's lots of ways that you can explore this managed identity setup. But it doesn't change your app, so it's not as fun to look at, but it's really, really important. And it's something you can use with basically any Azure resources if you're posting on container apps, app service, et cetera.
Yep.
All right, so now we're going to look at another way to use 𝗕𝗏. So let's go over back to the slide. So this is user login. So one way that many people will protect an application is that they'll put a user login screen in front of it, right? And say, hey, if you go to this app, you have to log in and prove that you have the ability to use this app, right? Authenticate and authorize.
Yeah, authorization and authentication all the way.
Yes. So as you can see in this diagram, we have added in built-in auth. So I am using what's called the built-in authentication. This is a feature you can use with container apps or app service. It just adds on a login middleware to your application. If you don't use that, then you can use the MSAL SDK, and you can implement the login using the MSAL SDK. But this is basically the easiest way that you can just throw user login on top of your application. It's just some configuration, and then boom, you've got login, right? So we put on the built-in auth. That makes a little container app sidecar, and it'll basically intercept every request, look for, and check that request to see, like, hey, is this person currently authenticated? If not, redirects them to the login screen for that organization, gets them to log in using all like the proper fancy things like MFA and all that stuff, and then redirects them back to your application. So let's just check it out now, see what it looks like. All right, so here's the application. I'll just say sup, and as you can see, it now knows my name, and I've got a log out here, right? So let's actually look at that login experience, because I'll go in an incognito mode here and prove to you that it is making me go through the whole login. So since I wasn't logged in, it says, okay, you need to sign in. And then it's going to take me through the whole rigmarole. So I have to, okay, I got to get in here. Okay, so yeah, so here I've got my thumbprint. Okay, I had to use, let's count the number of factors here, right? I had to use my thumbprint. Then I'm entering the password. That doesn't count as a factor, right?
Yes, it does.
Oh, it does. Oh, that's the first. Okay. Then I got to open up my Authenticator app. All right. Going to open up my Microsoft Authenticator app, and there's a number there. I just had to do Face ID. That's another factor, right?
Something you are.
Something I am a face.
Yes.
Okay.
It is. It's something you are. It's.
Okay, I'm a face.
Yes.
I just did my Face ID again, just in case my face changed.
Yeah.
All right, so that was like 5 factors. I did crazy. But here's the thing is that I didn't have to code any of that, right? The nice 𝗕𝗏 engineers coded all of that for me, right? All I have to say is like, oh, as the person in charge of this 𝗕𝗏 tenant, I want to make sure that everybody who enters this tenant is going through the entire MFA process, right? And let's say stay signed in. And then it's going to redirect back to the app, and then boom, it knows who I am. So this is, I like to show the whole flow so that people realize, like, wow, like you really don't want to have to implement that entire MFA flow yourself.
No, you really don't. And the nice thing as well is that when you use user login, it's tying back, as Pamela said, to an identity already in your organization, but it's also possible in Entra to use third-party ones through Entra external identity if it's more like a consumer app, and then each user can have their own granular permissions. So obviously this app is very basic and there's not too much we would do, but if you were building something more complex, you might not want every user to have the same permissions running in the app, and you can configure that all in Entra and keep it nice and centralized, which is much easier to manage as well.
Yeah, we've got a RAG application that we maintain that uses access control based off the user's OID or the groups that they're in. And so we just look and say like, hey, based on this user, based on their groups and their ID, what documents are they allowed to ask questions about, right? So that's the kind of thing you can do as soon as you add on this authentication layer. So the question is, how did I do it? Like, what I'm really excited about is that in like the last few months, it got way easier to add this on and do it all with Bicep. And if you know me, I like when I can do everything in Bicep. I'm like the #1 Bicep fangirl around town, which is kind of bad too, because then everybody, when they want Bicep, they just come to me. Yeah. I'm supposed to be a Python developer for the record. Okay. Okay, so here you can see in Container App how the authentication is set up. So you'll have a similar screen in App Service, you're viewing that. So basically we say it's enabled, we say we want to redirect and where we're going to redirect to. And then it's associated with an Entra application. So if we click on that, we can see this Entra client app, and the Entra client app has some redirect URLs. It has the localhost. It really doesn't need that because this is only going to work in production. So what really matters is that it knows it's allowed to redirect back to that container app URL to this special built-in 𝗦𝗲 redirect URI. And you can set up all sorts of things here. This one's set up just to do basic login, just for, this is only for our single tenant. This is a tenant that Sarah and I in, so we can log in. But for example, like some of my colleagues here who aren't in the tenant, sorry, you can't log in. It's our tenant.
Yeah.
But you can, as you see, you can do multi-tenant as well. And you could also use Entra external ID in order to make customer-facing apps. And that's really cool because you can do like this one-time passcode, which is like the thing, like everybody does that now where you don't even have like really like a password at all. It's just you get like the message to your phone and you're like, all right, you put it in, right? So you can set up all kinds of things when you use external ID. Okay, so that's set up there. Now, what's really, really cool is that I set all of that in Bicep. And this is something that only became possible in the last year because they added this Microsoft Graph extension to Bicep, and this uses this new aspect of Bicep called Extensibility. So I use this extension, and by doing that, I can create graph objects. So here I make the Entra application. I say it's restricted to this org. I give it the redirect URIs. I set it up for OIDC login. And then what's really cool here is that for the way of setting up like the credentials for that application, before we had to use client secrets or certificates. And those were such a pain because it's a secret is basically a key. So we'd have to like store that in key vault. Some are super duper secure. Or the same thing with the certificate. Like you have to set that up. I still don't know how to set up the certificate. And then you'd have to like store that securely too. So what we have now, and this also came out in the last year, I think at Ignite, is the ability to use the managed identity, that one I've shown you earlier. We can use that managed identity as our credential. So we're basically saying like, hey, this managed identity is allowed to use this Entra application to do the user login. So we do not have to store any client secret or any certificate. And this is really, really exciting to me. So we create that, and then we have to tell our container app to use that. So this is how we configure the container app. Tell it what sort of forwarding behavior we want. Tell it that instead of using a client secret, it's going to use a override from the managed identity and just use that managed identity instead. And we just store the managed identity ID instead of storing the traditional client ID. Okay, so that's all possible now, and I'm really excited about, maybe just me, but okay. All right, so now we've got that all set up, right? So we saw 2 cool ways that we can use Entra. Are we secure yet?
Let's ask Defender for Cloud.
All right, let's see. Go over here.
No. I'll do it very Australian, no. But for those that watch Bluey. No, we've still got things to do here. But what we have here is container registry should use private link. Container registry shouldn't have unrestricted network access. Azure AI services should use private link, and Azure AI services should restrict network access. So now we're into the network. Now, I like talking about networks because I, in a previous life, was a network engineer. So let's have a look at what this looks like. We're now going to add on quite a few different bits, but they're all network layer. Now, be horrified as we add lots on to this next bit. Ta-da! So what we've done here, I promise it's not as bad as all that. We've added a few different things. So let's start with the internal stuff. We've now started to split things up and segment the network. And the reason we want to segment the network is for a couple of reasons. It's much easier to manage, but also it's to do with reducing the blast radius. So, and we say in security, assume breach. By that, we know that nothing is 100% secure. So we have to design our systems as if at some point we're going to get breached. I know it sounds like very negative, but that is the reality of the world we live in. So by segmenting things, we make it more difficult for if a part of our application or a part of our tenant was breached, having different network segments makes it harder for them to move between them rather than someone just kicking the door down and running everywhere. So we have put everything in a virtual network. And then we have separated different parts of this application into different subnets. And within those subnets, we also have an NSG, or a network security group, tied to those subnets. And again, this is like logically separating things out. We've also created in that back on the right-hand side subnet, that's where all our private links are as well, because we're keeping all our traffic internal. This is an internal app, so we're not accessing any of the public endpoints. So everything here is nice and private. However, we say that, but people may need to access this and do things from external. So we have also created a VPN gateway so that you can jump in and do your things. Pamela.
All right, so let me demonstrate that VPN gateway. So as you can see, this is what it looks like when we are not using that gateway, as it's an error. And that's good. We want to see that.
We want to see that because you should not have an application, you should not have any kind of resource facing the internet if it doesn't need to, because you're just, in security terms, I know it sounds obvious, but in security terms, by exposing something to the internet that doesn't need to be exposed to the internet, you're just opening up so much more risk. And in making, we would say you're making the attack surface much bigger, because then you got the whole wide world looking at it. So we don't want to do that unless it's necessary.
All right, so it's like this, but then I'm the developer, or I'm like an internal employee. So I do want to access this, so I can go to my Azure VPN client, and I'm going to find the right VPN connection here, and I'm going to click connect. And I've already done my login for this earlier today, so it's not going to have me re-log in. So I logged in with my Microsoft account, and you remember how fun that was. So I'm logged in here. I'm connected to the VPN. The VPN is using an Azure Private DNS resolver, so that when I go to a URL, it can hopefully resolve that into the private endpoint. So now, ready?
Yep.
Okay. Yay!
Yay!
All right.
Yes.
And let's just make sure the app is because I might have just loaded HTML, right? But maybe okay. And now you can see that internally it's able to access the OpenAI over the private link. So that's what we want the experience to look like for this stage of security. Now, how did we set this up? As you see, we did have to make a lot of resources. It is overwhelming when you look at your resource group after you've set this up and be like, okay, I've got network interfaces, I've got private DNS zones, I've got private endpoints. But remember, I wrote all this code for you. So if you want a similar setup, you can get that all from the Bicep, and you can check it out. So here, here's the virtual network. We've got subnets. I was saying we use the subnets in order to, what's the fancy security term?
Segment.
That one, yep. So we've got a container app subnet, which is just our container apps environment and container app. We've got the private endpoint subnet where we put the Azure OpenAI. The gateway subnet is a special one just for the VPN. It actually has to be named exactly that.
Yes.
And then there's also a special one just for that Azure Private DNS resolver, so that the VPN can get to those private things. And then we've got lots and lots of other stuff. You can look at it later. But in the end, that's what it makes. It's all connected, and it's all working. So let's look at Defender for Cloud. Uh-oh.
Oh, okay. So as you can see, we have reduced our recommendations, but now we have a new one. So, in which you may not have noticed, but this was not there before. So it's saying virtual networks should be protected by Azure Firewall. Now, this is an interesting one. So what it's saying is that the virtual network that we've created, I'll flick back to the diagram. The virtual network that we've created there, you see the sort of larger dotted line that's all gray, should be protected by an Azure Firewall. This has nothing to do with the external access and the VPN. It's saying that we should put a firewall around all of this to protect it from the rest of your Azure tenancy. Now, I personally think for an internal-only application, that is overkill. And Azure Firewall works at layer 3-4 of the OSI model, the OSI layer model. And so that means we block and allow on IP addresses. Now, an NSG also allows and blocks on IP addresses and port numbers. Do not take away from this that I'm saying an NSG is equivalent to a firewall. It isn't. But for when we're doing internal apps, adding an Azure firewall, we have to start to play around with routing again, can make it really complicated just for something internal within your tenant. So I would say that would be optional. And I would go refer to your security architects and whatever you do larger within your architecture and cloud as to whether that firewall is actually necessary. But there's a controversial statement that maybe you don't need that. However, for the next bit, we are going to need a firewall.
So here's the thing, Sarah. I actually want my app to be public facing.
Why? Why would
I like people to come to it and like see my amazing applications.
Cool. You want the whole world to ask questions.
That's honestly like, when I was a kid, like in middle school and discovered programming, the first thing I made was like a Mad Libs. And like then like thousands of people from all over the world came and entered my Mad Libs. And that's, I'm addicted to making public facing websites.
Fair enough. So if we did want to make this public, we need to configure an egress point, and we want to make one that's secure. So we're going to look at adding WAF and Azure Front Door. So you can see we've added a little bit in the bottom there. We've added a web application firewall that opens up to the public internet, and then that goes back into our application. Now, if you ever put a web application on the internet, you must put a web application firewall in front of it. A web application firewall, if you happen to not know what one is, it works at layer 7. It looks at common web attacks like cross-site scripting, like SQL injection, etc. Now, when you do this in Azure specifically, you can't deploy a WAF by itself. If you go and search, you'll see that you get WAF with front door or you get WAF with application gateway. There's no such thing as WAF by itself. And the reason for that, and how you decide which one you want, is to do with your traffic distribution. So Azure Front Door is our CDN, and you can use Front Door separate to WAF. You just can't use WAF separate to CDN. So Azure Front Door, if you expect your app to have traffic from all over the world and communicating backwards and forwards from globally, you'd want to use Front Door because that's our CDN. If you're only doing regional traffic, then you could do WAF with application gateway. That's the difference between them. So for this, we're going big and we're going front door. So yeah, we're ambitious. So we've got front door and we've got our WAF. Now, for the OSI folks, if you've done your CCNA, like I know many people have once upon a time, then your web application firewall works at layer 7 of the OSI model. And application gateway and front door takes care of that layer 3, layer 4. So we don't necessarily need to put a separate Azure firewall in, but some folks and some architecture people in your organization may require that from you as well, although I'd say it's not necessarily required. Okay, so.
Did you prove it works?
Let's prove it works.
All right, so I have disconnected from the VPN, so I'm not on any VPNs. Let me reload this page here. If you can see from the URL, it's really small, but this is an Azure front door URL. And actually, you could also see that it very quickly did the login check too. I'll do that again so you can, it's so quick. But you can tell I'm logged in. I'm also just gonna say, sup boo. And you can see that I'm logged in, it's got my name, so this is working, right? Now, to really prove it's working, let's visit the private endpoint. And here, it looks like it's working. I'm gonna refresh here. And as you can see, this private endpoint is erroring, right? So the private endpoint is still private. The only thing that's public now is that front door. That is the only way to get into our app. And we've actually set it up so that the front door has what's called like this shared, what do we call it? A shared private link resource. Yeah. So this is the front door Bicep. You do have to use premium when we're doing connections with private links. And so we basically tell this front door like, hey, you're going to be directing to this container apps environment over this private link, right? So only the front door can do that. We can't just do that, as a user from our browser. But if I need to, I can still set up a point-to-site gateway, and then connect on VPN. There we've got a different VPN here, and I can go ahead and refresh and here. So as a developer, I still do need a way to get in, because when I'm developing, so normally when I'm developing, I develop using the Azure Developer CLI, which can both create provision resources and upload the code. Now we can provision resources without being able to get into the network, because that's just using like kind of the Azure portal API. But when we want to deploy the code, that means we're taking the code that's on our machine and we're zipping it up and we're sending it off to the cloud, to the container registry. That container registry is on a private endpoint.
Yep.
So if I try to do this AZD up when I am not on VPN, I will get an error at the point where it tries to deploy the code to the container registry, because it says, hey, I can't find this thing, like I can't get to it, right? So at this point, only the developers actually need the VPN. Before, like also like the internal users would need the VPN, but with this setup, only a handful of developers actually need the VPN access to be able to deploy. So there, that is set up. So as you can see, this is the WAFF policy here, and Sarah's going to tell more about this WAFF again.
Yeah, so when you deploy a WAFF, it comes with a set of what we call managed rules. They're predefined by Microsoft. We do update them. There's quite a few different ones. If we scroll down here, you can see there's a lot of them. We've got things for common web vulnerabilities like OWASP, Open Web. I didn't say what OWASP was. Open Web application security projects, so things like SQL injection, they're the folks who make the top 10 web vulnerabilities. We also block things, so cross-site scripting, SQL injection, etc. We also add our own rules in based on Microsoft Threat Protection too. You can see there's a lot, but it's also possible for you to configure your own rules if you want or need to. So that is our managed rules. But I reckon, Pamela, do you want to hack? Yeah, I'm going to show you some elite hacking skills.
All right, Sarah's going to hack.
And when we say hack, we don't really mean hack. But what I'm going to do is, and this is if Sarah can drive the Mac more than anything. Honestly, the hacking we're doing here is more, honestly, Sarah driving Pamela's Mac more than anything. But what I'm going to do is a super basic cross-site scripting injection, or attempt to do some very basic cross-site scripting. So what I've got here is the URL to the front door, and then we've put at the end, cross-site scripting script. This is like elite hacking activated right here. Now if I try and do that though, it is still technically an attack, and we can see that the request has been blocked, as we would expect it to be by any good WAF. So the WAF has blocked that request before it's even hit the application, which is what we want it to do. And if we have a look as well, we can find in the front door, we've got here as well, we can look at our security reports. So we can see here, this was me messing around earlier. We can see this is the security reports where we've had things have been blocked and things have been logged. If we go down, it will tell you which rule was triggered, where it came from. This was me in my hotel room, I think, after I got here. And it will tell you the URL. If we can get any information about the agent, we get things like that as well. So now we are now protected against web attacks, which is lovely.
Yeah, all those script kiddos, man.
Yeah, I know.
All right. So now I'm feeling pretty good here. And if we look for Defender of Cloud, we still see that done recommendation. But there's a way to hide this, right? If we talk with our security team and they agree?
Yes, there is. So yes, as I said, these recommendations are never going to be completely gospel and prescriptive for every single organization. Sometimes there are legit reasons you can't do things, whether it's tech debt or whether there's some other reason. And you can, in Defender for Cloud, if there's a particular recommendation like this, let's say we've decided we think firewall is overkill, we can mute that recommendation so it stops appearing as well, so it's not on your list constantly. So we can do that with any of the recommendations if you want to or need to. So you can have a nice, clean, completed Defender for Cloud.
All right, so I'm going to go ahead and wrap up while Sarah goes around.
Something I do, I could throw them, but this usually gets quite, people get can get quite aggressive. So I'm coming around with, you can have an Australian biscuit. That gentleman's gone to sleep.
These are Tim Tams. Who knows Tim Tams?
Would you like a biscuit? You can go and look at, I do this during my talk for no particular reason, apart from security loves you. So if you've been burnt by security folks in the past, please love us from now on. Whilst we do that, Pamela's going to tell you about where you can get other things from and some of the other sessions you should go to.
Okay, so the most important thing is all that code I lovingly wrote for you. So that you can get from the repo that's up there. You can either copy the URL or go to the QR code. They'll both go to the repo.
Pass them down.
And you can always file issues if you're having any problems deploying it. I've set it up in such a way. Let me actually switch back to the repo to show it. And I'll go back to the QR code, don't worry.
Pass them down.
But here you can see in the repo, I've set it up so that you can just decide which of these things you want to turn on. It's just a bunch of AZD environments that you set. So you say, oh, I want strict RAI, I want monitoring, I want keyless auth, I want VNet, I want ingress, I want front door. I'm not going to promise you can do every possible combination of those, because generally it's a progression, but you can turn things on and off. So for example, we were actually having an issue with the built-in auth this morning with front door, with compatibility, because the issue we were having is that when we enabled built-in auth for front door would end up redirecting back to the private endpoint. And we're like, uh-oh, we need to somehow tell built-in auth that it should be redirecting back to front door. And so we went, and luckily I got an email this morning that said how to do it, and made the change, and it just involves setting this header, right? So as an example, sometimes there's some, as you add on more features, you have to figure out exactly how to make them compatible with each other. But in theory, if you want to, not everybody's going to use user login, right? Because if you're doing something entirely inside of VNet, maybe you feel you don't need the user login, right? So you can mix and match some of these. It just depends on your situation. So it is all set up so that you can deploy it, provision it, and and run it locally. I also have cost estimates here. This is not free. There's a lot of difficult, complex architecture involved here. So I have put price estimates for all of these here so that you can get a feel for what the kind of costs are going to be as you increase the security. Now, ideally, we would just make everything free so that everybody could have perfectly secure apps all the time. But it does cost us money to run these things. So there's the pricing information. So you can try it all out in the repo, and you can let me know if you have any issues or questions about it. Okay, I had to show the code.
That's fine. So hopefully you enjoy your Tim Tams, and there are some other, we're only on Monday, of course Build goes for most of the week, so there are some other security sessions. If you're interested, you should go to a Build. On tomorrow afternoon and Thursday morning, I'm helping run the AI security testing with Pirate, which is our open source tooling that will help you test your prompts and your AI apps. So please come join us. We're going to be just over there. Pamela, you're doing a demo?
Yeah, tomorrow I'm doing a demo. It's a 50-minute demo. It's basically like automated trolling. It's called red teaming, but we can also think of it as automated trolling. So, set a bunch of trolls on your app automatically, and you'll find out whether your app gives out unsafe responses. So I will show you how to do that in the demo tomorrow.
And then on Thursday morning, we've got a breakout session called Reflections on 25 Years of Writing Secure Code. That's by my podcast colleague, 𝗦𝗽𝗲𝗬𝗀. If you know of him, he wrote one of the very first secure coding books back in the early 2000s. He's still here at Microsoft. He's been here for 33 years. It's crazy. He's an old school Microsoft guy. He's talking about how secure coding has changed and kind of what he sees as the challenges coming up. And he's a great storyteller. So I would definitely go see Michael if you don't have anything else on Thursday morning.
And there's one more.
And so there's one more. Well, I forgot there was also, here's the session details page and the session survey QR code. So if you, please give us your honest feedback if this was useful and if you liked it. Also, just on the corner here, as you go out, I always bring a ton of stickers, so please come help yourselves. And then, yeah, that is it. And we've got still some time.
We have 7 minutes for questions, so you can come up to the mic if you do have any questions. Ask something really tough security-wise for Sarah.
Yeah, and yeah, please do. Or if you're all done, you're free to go, but please help yourself to the stickers on the way out too.
have one question about everyone's favorite topic, insider threats.
Go with
We
it.
didn't talk much about it, but
Could you
let's say
speak
have-
into the mic a little bit more?
Yes, definitely.
Thank you.
Let's say you do have an insider threat, okay? And obviously, they might be able to access the VPN, delete resources in the environment, maybe delete the entire WAF in the application or
Yes.
your application gateway, your front door, whatever. What would be a great way to protect against that? Would you maybe think about using Azure policy and different custom policy templates to be able to maybe detect that immediately, redeploy those resources, or maybe lock that user out if they're doing things in which you might consider inappropriate?
Yeah, so that's a great question, and there's not one answer, as is often the case in security. So, if you have an insider threat, and if anybody doesn't know what an insider threat is, that's someone who is usually part of your organization and already trusted. So, of course, if someone trusted goes rogue, that's more difficult to deal with. So, if in the example of our application, a trusted developer will already have access to the VPN. So that isn't going to, having the VPN isn't a protection. So we normally say with insider threats, there's a couple of things. And remember that all security controls aren't always technical. We usually have a mixture of technical, process, and people. So insider threat often doesn't come under technical. So when you, and I'm sure many of you, when you've joined the organization you work for, you've done a background check. So we check people's backgrounds, we take references. Again, this reduces the risk. I'm not saying eliminates, because we never eliminate. It reduces the risk that someone might be bad. But we know that someone might have a change of heart as well, if you've worked for a company forever. And when that happens, we look at, we can do ongoing background checks if someone changes roles. And then when we move into kind of more the technical side of things, we do have, in managed identities and Entra, we do have, what do we call it now? UEBA, User Entity Behavioral Analysis. And that's when a particular user starts to deviate from their normal pattern of behavior, and it would flag as a risky user. So for example, if that user who's never deleted anything ever suddenly is mass deleting everything, that would raise an alert, and then we would feed that into your SIEM, your security monitoring, etc. Now, the problem is, of course, if that person isn't a dev, they should not have access to delete things. That's another thing, the principle of least privilege. Someone should never have more access than they need to do their job. But say this is someone who is a dev who should be able to delete things, then it's more the alerting and getting a hold of it and containing it as much as we can. Insider threat is very tricky. We certainly could. It is possible as well. You could use Azure policy to redeploy it immediately as well. But yeah, there's no one way, but there's layers of things we can put in to try and reduce it. So that would be what I would do. No worries.
So I'm going to shift away from the cloud-hosted services onto on-prem for a moment. So consider agents and MCP servers running on-prem. They're typically deployed with an API token or a service account. So they're using fundamentally a trusted subsystem model. And certainly, when the user submits a prompt, they're asked to validate that you authorize this operation to take place on your behalf. However, when that operation executes, it executes under the identity of the MCP server or the agent, which poses a security auditing challenge. Because now it's that service that's performing the operation. It's that operation with that service's identity, it gets logged, and that poses a challenge with, an audit trail. So how would you recommend mitigating that?
Okay, so I'm going to give you this is funny because MCP has been a hot topic for the last 6 weeks or so. I'm going to be honest with you right now. We don't have a good way to deal with that, and it's not just on-prem; it's the cloud stuff too.
So to that end, is there plans as MCP continues to evolve to enable the on behalf of flow?
I believe so, yes. So obviously, as you know, MCP is open source. Microsoft is quite heavily, there are particular contributors within Microsoft who are helping with that, and I've been privy to some of the working groups we have in Microsoft. Certainly, it has been identified by pretty much everybody that on behalf of thing is a deficiency at the moment and a weakness. And I don't I can't tell you like when it's coming. There's definitely been, and if it's definitely coming because it's open source, but there's definitely work to be done there. I can tell you that between about a month ago and now, they already changed the authorization spec to allow a third-party authentication server to step in, like Entra, Okta, you know, whatever. And that's kind of the first step, but the authentication piece generally and how it works on behalf of is still very immature because it's so new. So you're right, I can't tell you, I would be amazed if it doesn't mature and we get that, but currently, yes, there is no good answer to that. It's only acting on behalf of something else, which makes the audit piece really difficult. And I think at the moment, all we can do is be aware of that and make sure that if people choose to implement it, they're aware that's a current deficiency in how it's set up.
So Ian, one of our colleagues that works on that, he's here. We saw him.
Yes, he's here.
So
yes.
if you look up 𝗦𝗽𝗲𝗸𝗁𝗁𝗲𝗂. He's done a couple blog posts. Actually, one of the blog posts did have the on behalf of Flow. But find out, see if he's doing any sessions. I think he at least has like a keynote or something.
Yeah, he does. Yeah.
He's also a really good one to talk to because he's also working on the authentication.
He was a heavy contributor to the authorization that was just merged in. But it's a I know it's cheesy. It's a journey. There's like a couple of bits to get to, but certainly there's quite a bit of maturity that needs to come for the MCP stuff, for sure.
Thank you.
All right, I think we're going to get kicked out now. Thank you, everyone. We'll be outside if you want to ask more questions. We'll
hang around if you want to talk one-on-one. We'll hang around outside whilst they swap the room over. Thanks, everybody.